Namaste. Welcome to the next video of Machine Learning Practice course. In this video, we will discuss how to implement k-nearest neighbor with sklearn. We will mostly be doing this discussion in the context of classification. So as you know, nearest neighbor classifier is a type of instance-based learning or a non-generalizing learning. It does not attempt to construct a model, but it simply stores instances of the training data. Classification is computed from a simple majority vote of the nearest neighbor of each data point. There are two different implementations of nearest neighbor classifiers in sklearn. One is KNeighbors Classifier and second is Radius Neighbors Classifier. So let's see how KNeighbors Classifier and Radius Neighbor Classifiers differ. So KNeighbors Classifier learns based on k-nearest neighbors, whereas the Radius Neighbors Classifier learn based on the number of neighbors within a fixed radius R of each training point. KNeighbors Classifier is most commonly used techniques, whereas Radius Neighbors Classifier is used in cases where the data is not uniformly sampled. In KNeighbors Classifier, the choice of the value of k is highly data dependent. Whereas in Radius Neighbors Classifier, we used fixed value of R, such that the points in sparser neighborhood use fewer nearest neighbors for the classification. Let's see how to apply KNeighbors Classifier. We instantiate a KNeighbors Classifier without passing any argument to create a classifier object. So we import KNeighbors Classifier from sklearn.neighbors module. And in the second step, we call fit method on the classifier object with training feature matrix and label vector as arguments. Let's say how to specify the number of nearest neighbor in KNeighbors Classifier. So there is a parameter called n_neighbors that we need to basically set. So here, while instantiating object of KNeighbors Classifier, we set n neighbors to the desired value, and the default value of nearest neighbor is 5. So there is a possibility that we can assign weights to the neighborhood. So the idea here is that the higher weights are assigned to the nearest neighbor so that they contribute more towards the labeling of the new point. The weights can be uniform, where all points in the neighborhood are weighted equally, or weight can be based on the distance. The points that are closer will have greater influence than the points that are further away. By default, KNeighbors Classifier uses uniform weight. So can we define our own weight? Yes, it is quite possible that we can define our own weights as a function of the distance. So the weight parameter also accepts a user-defined function which takes an array of distance as input and returns an array of the same shape containing the weights. So here we have shown an example of a user-defined function. So here in weight we are specifying a user-defined function which is user_weights, which we have defined over here. It takes an input which is array of weights. As an example, we are just returning the weight array that we receive in the argument. But it is possible that you can perform some computation over here and return an array of the same shape as the argument. So let's see which algorithms are available in sklearn to compute the nearest neighbor, because nearest neighbor computation is the most expensive operation in the KNeighbors Classifier. We can use algorithm like ball tree or KD tree, or we can use a brute force search. So ball tree is specified with ball_tree, KD tree is specified with KD_tree, and brute force is specified with brute in the parameter algorithm. There is also an additional value that algorithm parameter takes, which is auto, that decides the most appropriate algorithm based on the values passed in the fit method. So by default, the algorithm parameter is set to auto. There are some additional parameters for the tree algorithm. For ball tree and KD tree algorithms, there are some parameters like leaf size that can affect the speed of the construction and querying the tree, as well as the memory required to store the tree. The default leaf size is 30. We also need to specify the distance metric for the tree. So it is either string or a callable function. There are few options that are available here, which are Euclidean, Manhattan, Chebyshev, Minkowski, Mahalanobis, etc. The default one is Minkowski with the power parameter set to 2. So that was about KNeighbors classifier. Let's look at the other classifier, which is Radius Neighbors Classifier. Here, if you want to use Radius Neighbors Classifier, in the first step you need to instantiate Radius Neighbors Estimator, and Radius Neighbors Classifier is implemented in sklearn.neighbors module. In the second step, we call the fit method on the classifier object with feature matrix and label vector as arguments. Let's see how to specify the number of neighbors in Radius Neighbors Classifier. So as we have seen earlier, we specify, instead of specifying the neighbors, we specify the fixed radius r, which is a float value, and that radius is set in the parameter radius in the constructor of Radius Neighbors Classifier. The default value of r is 1. There are some parameters for Radius Neighbors Classifier like weights. Again, it could be uniform, distance, or it could be callable function. The default weight is uniform. And again, just like KNeighbors Classifier, we can use algorithms like ball tree, KD tree, brute force search, and auto. Auto decides the appropriate algorithm based on the values that are passed in the fit function. The default leaf size is 30 and the default matrix is Minkowski with the value of p set to 2. So in this video, we discussed couple of nearest neighbor classifiers implemented in sklearn.